So, hello guys and welcome back. So, today we will be continuing with our real JEE Advanced test series, real JEE Advanced question series. So, guys, the question that you right now see on screen is once again from the Maths Explorers test series. And this is a really good question that every one of you should try out because it's a really unique question and I have never seen anything like this before. Okay. So, without further talk, guys, let's start off, I guess. So, if you want, you may try your hands out on this question first. Maybe I will wait for a few seconds. You can pause the video and try. I will wait and then I will also start off solving this. Okay. So guys, I hope now we can go with this question. So the question reads something like this. There is a family of lines f which is represented by this equation where a is a parameter that can take any value in between 0 to 1, both open. Okay. So 0 and 1 are not included. A curve C is the locus of points such that every member of the family of lines of f is tangent to the curve at some point. Okay, so they are basically trying to say that every line belonging to the family f will be a tangent to the curve C at some or the other point. Okay, and obviously x and y both are greater than 0, so we are all talking about the first quadrant, right? Now, if the area of the region enclosed by the curve C, y-axis and x-axis is equal to A, then the value of 24A is equal to. So basically, that's the thing we have to solve. Okay, so I guess to find out the area, we first need to find out, very obviously, the curve C, what it is actually, right? So guys, starting off, first is the family of lines F is given to be x by A plus of your y by 1 minus a is equal to 1, where your 0 is less than a is less than 1, right? So like I can treat this curve C that we are talking about, I can treat it like an envelope. Now why an envelope? Because this family of lines, like it's a random curve like this, and this family of lines is tangent like this. At some point it's like this, at the other it's like this, and so on, right? It goes randomly. So we don't know, like randomly or whatever, but our main objective is to find out the curve C. So guys, what I am doing is I am writing this capital F as a function capital F, okay? And it is a function of x, y and small a. And it is given to be equal to x by a plus y by 1 minus a minus 1 is equal to 0. Now guys, like if you remember what they said, that these lines are tangent to this curve. So if we differentiate this del f by del a, okay, like see, this is not perfect differentiation. I am partial differentiating with respect to a. Okay, you can, I guess you, if you want, you can write this as df by da also. Not a very big problem because here we will not have those dy by dx and stuff. But like better to write del f by del a. Okay, don't think this is something out of your syllabus. I am just partial differentiating to keep x and y constant. Okay. So we will differentiate del f by del a and put it to be equal to 0. Why? Because it is given that these lines are tangent to the curve. So this will become minus x by a square plus of your y by 1 minus a square is equal to 0. So from here we get, like if we do a little bit of crisscross, y will come out to be equal to x into 1 minus a whole square by a square. Okay. And after this, now what I will do is, we have got the value of y to be this in terms of x and a. So we will take this particular value and put it in the family equation. So if I do that, this will come out to be x by a plus 1 by 1 minus a into x into 1 minus a whole square by a square. And this thing would come out to be, I guess, okay, minus 1 is also there, is equal to 0, right? I just put it in the function capital F, or you can say I put it in the equation for the family of lines. So if you do a little bit of manipulation, or rather if you multiply the whole equation with a square, then you will get xa plus of your x into 1 minus a is equal to a square. Okay. So guys, after this, if you take a little bit of common here and there, this will become a plus 1 minus a. So a and minus a get cancelled. That means your x has come out to be equal to a square. right? So if x is equal to a square, then I guess we can proceed like this. Okay, so from here actually, if we put x equal to a square in this particular thing, then we will get your y as 1 minus a square. So actually we have a point. This is the general point on the curve, right? X equal to a square and y equal to 1 minus a whole square. So if you right now just eliminate the parameter, then it will automatically come and it's pretty easy. So y actually comes out to be equal to 1 minus of root x whole square. And this is actually the equation of the curve C. Okay. So like equation of curve C has been found out, which means we have actually no work to be done anymore. It's already done, right? And if you kind of see, like, we have to find out the area of this thing. So if we try to plot this thing a bit, I guess this will come out to be root x plus root y equal to 1. This is the curve, right? So guys, if we actually try to approximately like plot this, if we put your x as equal to 0, y is coming equal to 1, and if we put y as 0, x is also coming to be equal to 1. So I guess the graph will be something like this. Okay, wait, my line is a bit slant. I will try to draw it properly. So this is our x and y axis. And I guess the graph will go something like this. And after this point, actually, it will go up. If you can put the values and check, or otherwise, no need to do. But if you want to check the nature of the curve too much, it's urging you, then you can double differentiate and do all those comparison type and anything. Okay. Although it's not required. If you put values after one, you will automatically get that the value is increasing and very fast increasing. That's why the curve is going up like this. Okay. So this is 1, this is also 1, this is 0, which means that if we have to find out the area, we actually need to find out the area of this region. This is the region in which we have to find out the area, right? The red colored region. So guys, I hope this is not a difficult task at all. So if we move on to finding out the area, and the limits are also obtained, right? 0 to 1. So your area comes out to be integral 0 to 1, and this will be 1 minus of root x whole square, right? So very easy, just expand this. This will come out to be integral 0 to 1 minus 2 root x plus x dx. So done, and this will be x minus 4 by, I guess this will come out to be 4 by 3, x power 3 by 2, plus of your x square by 2, and limits are from 0 to 1, so this will be 1. I guess if you like solve this, this will come out to be 1 by 6, okay? And we were supposed to find out the value of 24 times a. So 24a would come out to be 24 into 1 by 6, which is 4. So 4 will be the final answer for this question. Okay. Like, pretty interesting question. It was, maybe some people might have found it easy, but it was given in a reverse type of way. So good question. Okay. So guys, I guess this will be the end for today's video, and I hope you have liked this question. So if you have liked my content, do like, share and subscribe. Anything doubts or anything else, you may come in the comment section, and do join my Telegram discussion chat because we are having really fruitful discussions there for your preparation. Okay. Anyways, that's it for today guys, and thanks for watching.